Jan LeCun recently argued that in 4 years, a child has seen 50 times more data than the largest LLMs today, trained on all the text publicly available on the internet, because the data bandwidth of visual perception is about 1.6 million times greater than the data bandwidth of written or spoken language. So he goes on to say, most of human knowledge and almost all of animal knowledge comes from our sensory experience of the physical world. Language is the icing on the cake. We need the cake to support the icing. End quote. So, what do you think about this? Do you think Jan LeCun's right? Do you think for achieving AGI, pursuing this language first approach, is the wrong route to go down, and we should be focused on
Mhm.
a bigger sensory experience?
So first of all, I don't disagree with Jan, and secondly, I would say that nobody's focusing just on language. If you take a look at what everybody's doing, if you take a look at the recent Gemini model, it's all multimodal. GPT-4 Vision. Everybody realizes if you can get more sources, more modalities of data, why not use it? PDFs, be it like sound and doing transcription using Whisper or whatnot. Every single data modality you can get your hands on, you should be using it. Back to Jan's hypothesis. That's something I kind of believe deeply since I got into ML. Every time I hear, hey, like LLMs use trillions of tokens, yet baby can just read like 5 pages of book and then she knows everything. No, like, dude, you're not counting in evolution. I mean, it's so obvious. Like, you are already an artifact in the search space of evolution that took billions of years, and that was computation on a very abstract. That's computation, and so you start from a checkpoint, and then so a
I love
baby is
that.
a base
Yeah.
model. Baby is a pre-trained base model, and
Uh-huh.
then on top of them, you do fine tuning of your life, and then you're also RLHF by the society into doing what's acceptable, what's not acceptable, and that's it. So I see, of course, like I'm falling prey here to the common historical thing, and that's comparing human cognition with what's currently available. People used to compare it with like initial analog computers. Before that, they were comparing it with mechanical devices. Now we're comparing it with LLMs because that's the closest we've got to AI, even though we still don't really know how to build general or super general intelligence, meaning better than humans. But we are getting there, and I don't see any reason why we shouldn't be scaling up. I agree with Jan in the sense. So the practical consequence of Jan's thinking is that we need much more compute and much more tokens, and we don't need to slow down. On the opposite, we need to accelerate there. So that would be my kind of conclusion from that hypothesis, which I think
And
I believe is correct.
and tokens not just from language, but from these other sensory modalities as well.
Yeah, yeah. When I say token, it's the most abstract thing ever, right?
Yeah, yeah.
Because if you read the Vision Transformer paper, for them, image is basically chunked into patches, and patches are just tokens. So in that sense, a piece of the image is a token. A piece of the speech is a token. Everything can be a token.
Makes perfect sense. In a Forbes article, you spoke about the second AI Big Bang being the introduction of transformers that underpin large language models. What do you see, or do you have any ideas, care to speculate, on what the next significant leap in AI technology where that will come from? I mean, so you talked just now about scaling up. I mean, that's one approach. Do you think scaling up on its own, scaling up existing architectures like transformers, with more data, more tokens, more modalities, that in and of itself will be enough to say attain an intelligence that is greater than all humans? Or
Hmm.
yeah, that was a long question.
Yeah, yeah. No, it's a great question. There is something special about efficiency and scale when you combine, like, again, referring to the bitter lessons by Rich Sutton. It turns out the algorithms that get selected as evolutionary more powerful ones are those that scale with data. They tend to stand the test of time. And so, looking at the current landscape and seeing how many tokens we are leaving back on the table, just think of video, think of YouTube. How many videos is there on YouTube, and how much data is not being used? I honestly believe it's not unimaginable for me personally to see the current approaches improving the engineering, improving our like infrastructure, having better AI accelerators, speed GPUs, or some of these custom chips. So working on that front just incrementally. I mean, when I say incrementally, it kind of goes exponentially, but just keep on adding more compute, more tokens, scaling up is gonna get us very, very, very far. Now, yeah, whether that's enough to get to general intelligence, I don't know, but it feels like it can. And the best reason, the best explanation I heard was actually from Elias Skiver, and he said something like this: "Why is the next token prediction such a powerful function?" So it's just predicting the next token. Why is that so powerful? And why is it the case that it can take us to general AI? And the reason is, I think, the following story he told, and that's, imagine you have like a crime story, and you have a couple of suspects in that story. Somebody murders someone. There's a detective. At the end of the story, the detective comes and says, "I know who is the killer. The killer is fill in the blank." And so for you to do just the next token prediction, the easiest way for you to do that is for you to understand the story. And that's the crazy part about next token prediction, because that's why all these properties emerge, because you're just trying to minimize that loss function to make it easier to predict. And then if you actually find the minimum will be if you understand the story. That's the easiest way you can predict the token. And that's it. And so because of that explanation, I had an epiphany moment, no pun intended, to my YouTube channel. Hearing Elias say that so concisely, a single sentence that made me think, okay, well, I think these guys are onto something. And he saw it much before many other folks. Definitely much before DeepMind folks, Demis and the crew. They've done an amazing job in science in particular. But like when it comes to scaling and everything that's happening right now, the sole credit goes to those guys. And of course, like Transformer paper did have a glimpse that, hey, these curves seem to be going down. But like I'm still mind boggled that nobody at Google was like, dude, if it's going down, why not push it a bit more? I mean, I understand why not, because you're in a bureaucratic machine and you have to ask for significant funds. And here you have a startup Silicon Valley mentality. And we're like, dude, I'm going to make this big bet that Transformers, when scaled up, are going to be amazing. And they went ahead to do that. And the rest is history. So like, I applaud them for that. And that's not a small thing. You have to believe in something that nobody has done before. It's much easier to replicate later and build another LLM.
Mhm. Do you think that approaches like those used for DeepMind's alpha geometry or the rumored OpenAI Q-star algorithm, where there's a blend of not just next token prediction, which you could kind of think of in Daniel Kahneman's thinking fast and slow kind of concept?
Mhm.
That next token prediction, like you and me just here having this conversation, what word comes out of my mouth? Like I'm not spending a huge amount of time deliberating on it. It's just flowing out. I'm in my thinking fast mode as we're here in this episode. And so it seems like there's kind of an analogy there to next token prediction that the leading LLMs today do. On top of that, when we finish this episode, I could theoretically, I wish this was actually what I was doing next. I could open up a calculus textbook and I could start working through problems. And then I'm not in that thinking fast mode. I have to slow down and deliberate and keep going back over the same information and consider each sequence of my thinking step by step. And so, yeah, so these kinds of approaches like alpha geometry, like OpenAI's rumored Q-star approach, involve this kind of thinking slow, this more step by step, deliberative, maybe not even linguistic in the case of alpha geometry. Do you think that that kind of thinking slow, some kind of mechanism there, in addition to a transformer architecture scaled up, could
Mhm.
provide some gains?
I don't think it's mutually exclusive. I don't think it's incompatible. And by that, what I mean is, if you saw, I mean, starting from chain of thought to tree of thought to all of those methods, where people are just creating, like, where the LLM is having an internal monologue and then using that to output something at the end, that's kind of simulating those types of inner monologues, and that's kind of the way we're simulating this internal system 2 thinking that you refer to, I would say. Now, Whether there is potential, I see definitely a lot of potential combining these methods with some types of um, tree search algorithms, something like Monte Carlo tree search that AlphaZero use. Those types of things. But we are already doing that, and we're doing that. I think we're doing that on top of LLMs. So in that way, I would maybe agree that LLMs are like system one thinking, and then what you do on top of LLM, be it like a monologue, or like creating multiple generations and then having some way to score those and pick the best one. All of that can be happening, and can be labeled as system two. This by the way, this reminds me of I don't remember the guy's name, but he had this theory of thousand brains, I think. And the idea there is that below your like neocortex, in the subcortical structures of your brain, you have all of these competing ideas. You're generating like thousands of ideas, and those can be maybe LLMs, whatever. And then there is some system on top of that that cherry picks the best ideas. That one wins and is promoted to your consciousness. And that's the thing you're kind of aware of. But like sometimes, and people, I'm not recommending drugs or anything, but people on drugs definitely seem to display some of these things where they just have a ton of thoughts that they cannot control. And my hypothesis, very layman hypothesis, obviously I'm not a neurobiologist, but like my suspicion is that the default mode network gets deactivated, and you just kind of you kind of your consciousness kind of drops down into the subcortical structures where all of these competing ideas are happening. And that's kind of why that's an additional proof, for a piece of evidence for why I think everything I said makes sense. Anyhow, hopefully.
Yeah, yeah. I love that example. I loved it. I loved it. And to give listeners a good sense of, for me, an experience without hallucinogens that shows me that same kind of all these ideas happening under the surface that are out of conscious perception, but are nevertheless driving your conscious perception, is it's been a while since I've had to write a multiple choice test, but back when I was an undergrad, we still did it with paper and pencil. And something that I would do is if I got to a question where I didn't immediately know the answer, I could say, okay, well, of these four answers, I know two of them are wrong. So I'll cross those two out. And then I wouldn't stress about it. I would be like, I don't know what the answer is between those remaining two, but I bet it'll come to me, and just keep working on the test. And then maybe 5 questions later, or at the end of the test, when I come back to this question where I crossed off two of the answers, immediately I know which
Epiphany.
is the correct from the remaining two. And so that for me was always a very tangible expression of that subconscious thinking. I spent zero time, the whole rest of the test, I was consumed entirely by the other questions. I didn't put a single instant of conscious thought on figuring out from the question that I didn't know. And nevertheless, my brain was there working on it and figured it out.
I mean, thanks God, because if we were like sequential machines, things would be a bit harder, right? We have all of these. You basically spawned a parallel process in the background, and I mean, to use some silly CS analogy, it's much more complicated than that. And of course, you can do that, and we've known that since antiquity, literally. Like, wasn't it that who was it, Archimedes or something, was in a bathtub when he realized, and he had this famous eureka moment. And like, I think even listening to David Silver, he mentioned somewhere on some of the podcasts I listened with him, when you really focus hard on some idea, and then he went to like a vacation, he was on a beach just laying down, all of a sudden he solved the problem. And yeah, there is this concept of like diffuse and like what's the terminology, like convergent and divergent thinking, right? From these courses like learning how to learn from Coursera or whatnot. And that's precisely that. Sometimes you're in a convergent mode where you're just like trying, you're kind of straining your prefrontal cortex, and then you go into the chill mode where all of these synapses actually start connecting, or whatnot. If that's what happens, again, I'm a bit of a layman in neurobiology, and similar to what like muscles do, right? It's not like the muscles form during the training. That's when you rip them, and then during the break time when you're resting, that's when the connections are being made. And so probably similar, because both are cells and tissues. I wouldn't be surprised that similar things and processes are happening in the brain as well. Might be a bit different, but anyhow.
Yeah, I think there might be some mechanical differences, but the analogy makes a lot of sense for sure.
Right.
Um, so, all right, cool. We've talked about integrating the LLM thinking fast system, system one in Daniel Kahneman's language, with some things that could be more like system two, deliberate conscious thought. Some other kinds of approaches that you've spoken about before as potentially being helpful for tackling unsolved problems in AI include the idea of integrating Bayesian learning, graph neural networks, and reinforcement learning. And so I don't know if you want to talk about that anymore here, if you have any further thoughts on that.
Hmm. Wow, you dig that up probably somewhere from LinkedIn years ago, because I don't remember when was I know I posted that somewhere at some point, but that was long time ago. So kudos to you doing the research.
This was in Analytics India magazine, AIM, in December
Ah,
2020.
okay, so as I said, 4 years ago, literally. Well, listen, back then, so what I've done there is very simple. I followed a very simple principle. You have all of these separate areas of ML which don't seem to be converging. So you have GraphML, which is a field for itself because it never went through the scaling laws. You have LLMs, you have Bayesian with all of this modeling probability. You have to model everything as a probability. And so it's just a bunch of disparate ideas, and there might be some cross connections across the fields. And that was my guess back then when LLMs were still not all the craze. I don't even remember if when that blog was published, whether it was already May 2020 when GPT-3 was first published. So anyhow, that was my best prediction back then. But like it was kind of I followed a silly principle. I was just like, okay, maybe some combination of these would be cool. That's it. There was no deeper insight there.